impact on your choice of indicators, how you evaluate models, and all these different things. So as this is an orientation session, I just want to give you like the 30,000 feet terminology here, but this would be something we would dig deeper into in an actual online session. So how do I decide whether the errors go from here to here, meaning from the construct to the indicators, or the other way around? Yeah, so how do I decide this, and which indicators do I have to use? Obviously, important questions. So in academic research, we have seen really a surge in use of PLS. It is really a hyper topic. Yeah, so many researchers use it, and this is just a keyword search in like academic databases on PLS SEM and PLS path modeling. These are just two terms that we use for this technique. And as you can see, the use of PLS really skyrocketed since actually first in 2004 to 2005, and then since 2012 and onwards. And there are many reasons why this is the case. It's very easy to use. It's what I would say a pragmatic approach to model like causal chains, like the chain that I just came up with. Quality leads to likability, likability leads to loyalty. It is easy to use, and it is a sound way of handling very difficult data situations. Let's put it like that, but I'm going to get to that in a bit more detail. As this training centers also talking to practitioners, might be wondering, okay, that's great that this is now important in academic research, but why should I care? You know? And here's why you should care. PLS is a fundamental and very important and still emerging technique in many marketing applications. So you might actually know one, the American Customer Satisfaction Index, ACSI. If you've never heard of that, Google it. Yeah, ACSI Institute. It's like a major institute in the US that regularly surveys some 100,000 consumers regarding their perception of different companies in different industries and different sectors. And what you get here are these scores that you see here on the lower board in this table. These are satisfaction scores. These are actually scores of this ACSI construct. And these scores are being derived in the context of such a PLS path model. So what you see here is actually the foundation for the computation of these scores that you see down here. These scores are super important. They're actually a warning, an early warning signal for economists, because you can basically say, okay, if customers are starting to get unsatisfied, this will trickle down in lower cash flow, lower sales, which will reduce the bottom line of a company, yeah, the financial power of a company. And this will also have a significant negative effect, obviously, on the economic performance. So the ACSI is actually also nowadays an economic indicator. It's being derived in the context of this model. So many companies use this to track their satisfaction and also to understand how to improve it. The model that you just saw is nothing that I came up with. Yeah, it's actually based on research at the institute where I worked in Munich. Yeah, maybe you know it from the Oktoberfest. Yeah, so I worked in Munich, and they developed this model, this institute, with several companies like BMW, like Bayer, like BASF, and many others, insurances, the banks, and so on. And they actually regularly using it in their marketing dashboards. I also worked with this several times. It's just one example. Lufthansa, German airline, you might know it. Yeah, they actually use this model to calibrate their customer targeting activity. So how do you target customers? Which customers should you target with which measures? And this was all based on such a PLS path model. So all of this is documented in various publications. We have written a book on this in case you're interested and you just don't feel like taking a course, a full-blown course, but you're interested in reading up on this. This is one thing you could do. You could also take one of the various translations, including one by Zakaria, who's actually with us, and he was introduced. He translated the primer, is currently working on the advanced book. He's done a fantastic job here. So this is also something to look for in case you want a German version. You can also. So what is, or how does it actually work? Yeah, and I mean, obviously, this is nothing we can cover in like 45 minutes, but I just want to give you a general overview. So these are the steps that you have to run through when working with PLS. First, you have to specify the structure model. Remember, the structure model, this is where the relationships between the constructs are being defined. Y1 leads to Y2, for example. How do you do that? And which relationships can you assume? Should these be linear? Should these be nonlinear? Should these be direct or indirect? Could there be something like a moderator which impacts the relationship? So there are many different things to look into. And this is the very first step, driven by your intuition and your business expertise, but also driven by academic research, theory, which tells us that Y1 should have an effect on Y2. And okay, we design the structure model and we test this. The second step is specifying the measurement model. So it's great that you have this fantastic structure model now, but how do I test it? I mean, where does the data come from? Which data do I need to use? And this is obviously a very challenging step because it requires us to choose indicators to measure something which we cannot observe directly. What is corporate social responsibility? What makes a company likable or competent? So these are very fundamental and challenging questions. And this is something where you actually need researchers to do the job. So sitting down, choosing ad hoc measures is not going to do the job here. You need actually experts who are trained in these things. And the course will give you an overview what to look for. So how do I specify the measures? Which indicators? Which questions do I need to use? Can I use secondary data? And if yes, which type of secondary data? Third step, I need to collect the data and examine it. This is nothing specific to PLS. This applies to all analysis procedures, whether you use a simple regression or you use random forests or some machine learning technique. You need to collect the data, scrap it, and examine it for redundancies, for outliers, all these things. The fourth step is simply in what we do here, clicking the button. You estimate the model. But there are different algorithms. Which algorithm is the best under which circumstance? This is something to look for. We then have to assess the quality of the models. Is it a good model or is it a bad model? Are my measures reliable and valid? You might be familiar with these terms. So reliability tells us whether we are actually measuring something. If we measure something repeatedly, we can be sure that we're doing a good job here. So stability over time, this is what reliable in its truest sense means. It's tested a bit differently though. And validity in layman's terms means, okay, are we actually measuring what we want to measure? We do this differently for so-called reflective and formative models because there are different criteria involved. And once we have confirmed the quality of these measurement models, we move on to the structure model. So which of the relationships are significant? Is the model doing a good job in explaining my target construct? So does the model actually explain something? And does it predict well? See, at the end of the day, when you're an academic researcher, you want to give recommendations to practitioners. So if you want to increase your loyalty, you should do this and that. This is the recommendation, right? But this is a predictive statement. So if you do this, that will happen in the future. And similarly, if you're a practitioner, you're not interested in testing hypotheses. I understand that. What you are actually interested in is predicting something. So how can I increase my satisfaction, my loyalty, my sales, my turnover, whatever you want to predict? This is something that we actually need to test in these types of models. And this is the final step. So when I thought about, okay, what can I talk about here? There are like two things that I want to focus on, like in the remaining 25 or so minutes. I want to give you a bit of an overview what this PLS SEM actually is and where it differs from other algorithms or procedures that you might know. So if you've never been exposed to structured equation modeling, this is going to be somewhat boring maybe, but hold on, because after that, I'm going to be talking a bit of the model about the model evaluation, so what to do. So what is PLS SEM actually? And this is a Swedish mathematician or econometrician called Herman Wald. And he actually developed two types of procedures, so not him personally, but his PhD students. One is called the LISREL approach, which stands for linear structure relations, and one is the PLS approach. LISREL is something that you might be familiar with if you have worked with structured equation modeling. This is what is being implemented in AMOS, for example, SPSS program, or M+. There's also a computer program called LISREL. All these programs carry out a so-called covariance-based structured equation modeling approach. Covariance-based basically tells us what this aim of this procedure is. I'm going to get to that in a second. Another researcher, Jan Bernd Lohmöller, he was a German. He developed the PLS procedure, and this PLS procedure came in different forms for different types of methods, like a regression, a discriminant analysis, and also PLS path modeling or structured equation modeling. And the PLS regression proved extremely popular in, for example, chemometrics, so the field of measuring chemical processes. Also in biology and also in medicine, PLS regression is typically used because it can handle situations where you have very little data, but very many variables. For example, once I estimated a PLS regression model where I only had 30 observations, but I had over 100 variables. So a regular regression won't do the job because you have too little information to actually run it. No, you don't get a result, right? But PLS regression actually tries to summarize, combine these 100+ indicators into a smaller set of constructs or factors, and then uses these as predictors. So PLS regression is a well-known technique in many fields. PLS SEM, or PLS path modeling as it was called earlier, was somewhat less prominent until like the late 90s, beginning of 2000, when some researchers in information systems dug it out and said, this is a great technique. And ever since then, it's been really prospered and really took off with the introduction of software like Smart PLS, which made the use really easy. There was also lots of research on it, statistical papers telling us about the properties of this method. Lots of discussion going on. Many of these are academic in nature. But this is not the right situation to discuss all these matters. Just to give you a bit of an overview what these two methods actually do. So both methods, CB-SEM, so LISREL, left-hand side, that you just saw, and PLS SEM, the right-hand side, they try to do the same thing, right? You have a model and you want to estimate it. But they take different routes to do that. One is trying to minimize the difference between the covariance that you actually observe. So the covariance is kind of the relationship between the indicators. And there's one that you actually observe, and there's the one that actually is implied by the model. And this is the aim of covariance-based SEM, tries to minimize this discrepancy. PLS, on the other hand, is a variance-based procedure. So it tries to maximize the variance of the dependent constructs, endogenous constructs. See that term here. So this basically means the constructs that you want to explain, where errors point at. So these differences have fundamental implications for many things. For example, covariance-based SEM has distributional assumptions, so the data need to follow a certain distribution, typically not a severe issue, but it could be an issue. PLS SEM is distribution free, so it's non-parametric, does not assume any specific distribution. It's probably most important for you is that CB-SEM generally requires large sample sizes, and with large, I mean sample sizes of say 200, 300 or more. You can get results with smaller sample sizes depending on the complexity of the model and how you specify it, but typically these estimates are not really reliable. So you can't say, okay, this is a good estimate. In PLS, you can actually estimate a very complex model with very few observations, similar to what I just talked about in PLS regression. So you've got many variables, sorry, and very few observations. And this is where PLS actually is very favorable in terms of its performance. Problem is, researchers kind of abuse this sometimes. They're lazy to collect data, and so they just say, okay, PLS does the job, so why do I need to collect? That's a good idea. Yeah, so PLS works better with many observations, but you get a result with small sample sizes, and it's probably a bit pragmatic. Yeah, I'm also a bit pragmatic here. I believe it's good to have a result which is close to the true value rather than getting no result. Yeah, but this is a matter of taste. The question also is, what is the true result? Obviously, we don't know about that. Yeah, but too much detail on this one. So something that this is now for the more advanced users. Yeah, a fundamental difference is that covariance-based SEM treats the constructs as factors. So this basically implies that you only use the shared variance of the indicators to identify this model, whereas PLS SEM treats these constructs as composites of indicators, so linear combinations of indicators. And so the total variance of these indicators is used to estimate the model parameters. So that's a fundamental difference. And for the statistical nerds in the community now, this is the point of discussion, whether to use the one or the other. So this has various implications for model fit testing, for whether you believe the one is better than the other. It basically boils down to this assumption. Are we looking at factors or composites? Yeah, but this is good for you users and saying I just want to gain an overview. This got not too many implications. Yeah, so this was more for those that have already worked with structure equation modeling. So bottom line, PLS is highly useful in situations where you have a very complex model and you have not very many observations. You have problems with the distribution, so it's very skewed, not nicely normally distributed, like a bell-shaped curve, but it's like left skewed, right skewed. And it also is very helpful when your aim is to predict, yeah, because PLS is a prediction-oriented approach to structure equation modeling. And this is typically what practitioners and also applied researchers are interested in. They want to test a theory in the context of a model which is supposed to predict something, because at the end of the day, we want to tell managers, okay, if you do this, this will likely happen. Yeah, this is a predictive statement. Covariance-based SEM does not do that. Yeah, it tests whether a model is correct, but it does not tell us whether the correct model is actually doing a good job in prediction. These are two different things. You can have a correct model, which is awful at predicting something, but you can have a wrong model, which is fantastic in prediction. Yeah. For those of you that have already worked in machine learning, this is something you will be familiar with. Yeah. You have a certain variable turnover, say, that you want to explain, and machine learning algorithms just stuff everything in, kitchen sink approach. Yeah, you just stuff everything in and search for the variables that work best. Yeah, no need for theory. Who cares about theory? Yeah, this is a purely exploratory approach. Yeah, so you can have a very good model which is not adequately reflecting reality. It's just doing a good job in prediction. And this is where the conflict is between these two methods. So PLS, strong in prediction, CPSEM, strong in testing a theory in the confinements of a certain model. Okay, so the model assessment. This is typically where the most problems come up and where the most challenges are. And this is just so that you have heard these different measures. Yeah, so there are basically these two types of measures that we have to assess. There are reflective measures and formative measures. Reflective, errors go from the constructs to the indicators. Formative measures, errors go from the indicators to the constructs. And there are different types of things that we have to evaluate then. It's things like internal consistency, reliability. You might have heard about that, like Cronbach's alpha. This is a popular measure for these types of analyses. Also, there's row A and row C, but these would be some things we would cover in the actual workshop. Similarly, convergent validity, discriminant validity, indicator reliability, these are all things we have to look into. And there's lots of developments here. For example, discriminant validity assesses whether two constructs which are conceptually different, so you put them into your model because you think they are different, you want to test whether they are also empirically different. So are they the same more or less, or are they really distinct also from a statistical point of view? This is important, obviously. And there's lots of discussion here how to evaluate these types of models. Things look a bit different here in formative measurement models. You have to look into something called convergent validity, which is different than active model part. part, you have collinearity, and you look in the so-called outer weights. They quantify the relationship between the indicators and the constructs. Once you have confirmed the quality of these measures, you would move to stage 6, the evaluation of the structure model. And there's different things to look into. For example, the explained variance, the R-square, coefficient of determination, something you might have heard about, the predictive power of the model. So does it actually do a good job in predicting something? And then you can look into also goodness of fit if you're interested in that. I'm a bit skeptical here, but this is something you could look into. And you could also compare different models. Say I've got model 1, model 2, which one's better? Okay. Okay, so this is looks very theoretic, yeah, I assume. So let's maybe take a look at an example. I'm just changing my screen here. Okay, and now you see a screen with the software. Yeah, so this is Smart PLS. This is a popular software for running PLS SEM analysis. And there are different softwares out there. You can also use R, and there's something called a Danko, and you name it. Yeah, but I'm going to focus on this one. And I'm going to click here on what's called the extended model. These are my different models here belonging to different types of projects. And if you take a look at this screen here, this will look somewhat familiar, right? This is exactly the model that we looked at on the previous slide. Competence, likability, we assume these to have an impact on satisfaction and customer loyalty. And just abbreviations here. So COMP, like, stands for competence, likability. CUSA stands for customer satisfaction. This is customer loyalty. And here at the left-hand side, we have the antecedent constructs: quality, performance, corporate social responsibility. And down here, we have attractiveness. So this is just a bit of a different order of the constructs, and it looks a bit different with the colors, but it's exactly what we set up before. So this model is something that you or I have to draw based on theory and logic, and then I gather data to estimate this model. And this is actual data here from a project with a mobile phone company. So this is actual data, no falsification, nothing. Yeah. So I didn't make this up. It's actual data from it was back then a consulting project, because this telco company was interested in managing their reputation. So this data set is a rather small one. We have only 344 observations, which you can see down here with this green screenness or this green text, and you have this number of records. So these are the number of observations in our data set. So I'm going to run this model now. You see different options here in the software. Standard PLS algorithm, but many other things that we can look at. And this is typically enough material for a 4-day workshop to cover all these things here. But I'm going to go with a standard one, the PLS algorithm. I get different options here for missing value treatment. I can weigh my observations in case you have an unequally balanced sample. I can compare different groups of data. But all of that's not mattering to me. I just go with the default settings and say start calculations. And bam, yeah, it's very efficient, meaning the algorithm is very quick. And if I go to my screen, I can actually see right away the estimates. So these numbers here won't tell you much, I assume, but just for your, just to guide you through this a bit, the most interesting elements are obviously these path coefficients, these relationships between the constructs. And you see these arrows with numbers on them. And these numbers are standardized regression coefficients. If you've ever worked with a regression, these will look familiar to you. If you run a regression model in, say, SPSS or Stata or R, you get the standardized estimates. Standardized estimates means they are standardized from a scale from -1 to +1. +1 means perfect positive relationship, -1 means perfect negative relationship, 0 means no relationship. And so we can actually compare these values here. If some path, some arrow has got a higher value, that means that it's more important for explaining the target construct. So let's take a look at this model here. So what we see is actually here my customer loyalty construct. And you see an actual number here in this customer loyalty construct. This is the R square. It answers the question, how age of customer loyalty is actually being explained. So am I doing a good job in explaining the emergence of customer loyalty, yes or no? And it says here, 56% of customer loyalty are actually being explained here. So this is actually quite okay. But the question now is, from a practitioner point of view, how can I actually increase my customer loyalty? So how can I make my customers more loyal? And if you take a look at the arrows pointing to customer loyalty, you see that there are different numbers here. And the biggest number is this, 0.505. It's linked to customer satisfaction. Well, the conclusion would now be, okay, to have more loyal customers, you need to have satisfied customers. Yeah, fantastic, yeah. This is not exciting, right? The question now is, how can I increase my satisfaction? And if you take a look at the arrows pointing to satisfaction, you can immediately see that competence plays a bit of a role, 0.146, whereas likability plays a much bigger role. And likability also has a very strong direct effect on customer loyalty, 0.344. So it seems like that likability is very important for driving satisfaction and also for driving loyalty. For example, you have a strong positive effect here from likability to loyalty, but also an indirect effect via satisfaction. So there's a causal chain here. You go from likability to satisfaction, from satisfaction to loyalty. So if you were now the manager, you look at this model, you would learn that it is important to be more likable, yeah, as a company. This will increase your satisfaction and your loyalty. It's better than being perceived as competent, which has got almost no effect on loyalty and a very limited effect on satisfaction. So competence seems not to pay off really. But how do I increase my likability? How do I do that? Yeah. Well, if you look into the arrows pointing to likability, you see that attractiveness has a small effect, CSR, corporate social responsibility, has a small effect, performance also has a small effect, but quality has a pretty pronounced effect compared to the others, 0.380. So the conclusion here would be, okay, when you increase quality, this will increase likability, which will increase satisfaction and loyalty. So this is a construct called perceived quality. The question could now be, okay, how do I increase my customers' perceived quality? I mean, you can have objective quality, that's right, but typically it's about perceptions. So the best quality doesn't help you if customers don't perceive it as such. So in this case, you could actually look at the indicator level here. See these indicators, quality 1, 2, 3, 4, 5, 6, 7, 8, 6, 7, and 8. These are all linked to quality. And the question now is, which of these quality indicators has got the strongest impact on quality? And you see here, this is quality number 6. So if you increase quality number 6, this will increase quality perceptions, which will increase likability, satisfaction, and loyalty. So it's a causal chain going from here, down here to loyalty. And you can also take different routes, by the way. You know? So quality 6, just for your information, is the answer to the question. I believe this company, whatever that is, yeah, your company or another company, is a reliable partner for its customers. So it's about perceived reliability here. So if you want to increase your perceived reliability, yeah, you're being friendly and reliable to your customers, then this will increase the quality perceptions, which will increase likability and customer loyalty. Now you can probably see why this is actually such an important technique, yeah, because it gives us an indication of sorry, I was just distracted here for a second because there's like a survey popping up. I just got to get this out of the way here. Oh, there we go. Okay, sorry about that. So this is just one thing you can do with this type of model. Yeah. There are different things to look at. We could look into the predictive performance of this model. We could compare different groups. We could actually try to find groups which are hidden in this model somewhere. We could also look into moderators, which impacts the direct effect of, say, quality on competence. Maybe gender has an impact here. Is this true? Yes or no? So there are different types of things that we can look into. One particular nice thing, and I just want to drop this by real quick, performance map analysis. So I'm just going to initiate that and show you the results. And this is something that you might be familiar with when you're working in practice. It's like a 4-field quadrant scheme, like this BCG matrix. On the x-axis down here, you have the total effects. So the effect of a certain construct on some target variable, and the target variable is customer loyalty. And you can see the different colors here. These are the different constructs. For example, attractiveness, that's a red square here. Competence is a blue circle, and so on. On the y-axis is the performance. And the performance tells me something of how good of a job am I doing. For example, is the perception of my corporate social responsibility good or bad? Is it high or low? And this is being rescaled on a scale from 0 to 100. So I can be very good at something, and this can have a very strong impact. And I would be in this quadrant over here. I could also be in a quadrant down here where I'm not being really good. The performance of, say, my corporate social responsibility or whatever it is not really high, but this construct has got a very strong effect on my target construct. Then I would be somewhere down here. Well, the third quadrant would be a case where my performance is low and it doesn't matter because, well, it doesn't have a strong impact anyway. And there's one quadrant over here where my performance is actually pretty high, but these constructs do not really matter for explaining my target construct. So you can kind of set up a 4-quadrant scheme and derive recommendations based on where these constructs are. So in my case, for example, I can see that likability has got a pretty strong impact on loyalty. But if you take a look at it, it's not really bad. Yeah, I've got a score of 53 here. So this is my performance score, or it's 57, I think, 57, yeah. But in terms of the absolute performance, this is not fantastic. So I should invest in increasing my likability to move up here. Quality, for example, also has a somewhat stronger effect. And it's actually, compared to the others, doing okay. It could be a bit higher. If you compare that to corporate social responsibility, I'm not performing really well here. So the score is roughly 50. It's the lowest one. But this doesn't matter either because the impact of corporate social responsibility activities on my customer loyalty is not high. It's very much to the left-hand side. You see here, it's a 0.112 effect, something like this here. So the bottom line, this learning from this graph would be, okay, don't invest in corporate social responsibility activities, also not in your company's attractiveness, but try to strengthen likability and quality. That would also be something. Okay, so with this being said, that was a very brief overview of PLS SEM, what it does, what the steps are. I hope you appreciated that. We actually planned out a full-blown workshop with 2 modules on this technique. Module 1 would be a basic level where we discuss all the different, or how to set up a model, how to gather data, how to estimate the model, how to assess is it a good model or a bad model, and also assess the predictive power. In the advanced level, we would look into topics which are typically more relevant for researchers, but not exclusively. For example, this importance performance map analysis that you just saw, that's a bit more advanced, and we would cover this in the module 2. But other things like multi-group analysis, unobserved heterogeneity, latent class analysis is more for researchers, but it doesn't mean that it doesn't have implications for practitioners. So don't get me wrong, it's relevant, but typically researchers use these things. Maybe we should change that. So with that being said, thank you very much for your attention, and still we have some time for questions, I assume.
Yes, we do have like 5 minutes for questions. There are a couple of questions were asked in the chat box, and as well I see Musa, I believe, raised your hand. You have a question, Musa?
Yes, I have a question.
Hi.
First of all, let me thank the Prof for a wonderful presentation.
Thank you.
Okay, so my question is about the secondary data. Can we still use the PLS to analyze secondary data?
Yeah, actually, that's not a problem. The thing with secondary data is that it doesn't typically follow these carefully crafted psychometric requirements of measurement. Like when I want to measure likability or competence, I mean, there are herds of researchers which clearly define which type of indicators to use. Yeah, so very carefully crafted. With secondary data, you typically don't have that luxury, right? You just get the data. And so in terms of measurement quality, secondary data are complicated, not really forgiving. In covariance-based SEM like AMOS or so, it would be very, very, very challenging to get the model up and running because the secondary data does not follow these carefully crafted requirements of measurement. In PLS, this is not a problem. It's, let's say, very forgiving in these regards, and it allows you to use all types of measures. Where we see limitations, though, is like streaming data. If you have a constant stream of data, longitudinal, then PLS in its current form can't handle it. Yeah, but generally it can.
Thank you.
Okay.
We have another one asking for a question. Mr. Sayed, please, I will ask you to unmute. Please unmute yourself if you would like to ask your question.
Hi, Assalamu alaikum, sir. Ringal and Marko Sarstedt, thank you very much. Sir, I am from Pakistan and I am asking about consistent PLS algorithm.
I had a problem understanding, or like the connection was really bad. Sorry about that. Can you repeat maybe?
Maybe repeat it or like type it in the chat box. I think it will be more clear.
Sir, I will try. Sir, I asking about consistent PLS or simple PLS in smart PLS. Some people said with the reflective model you should use consistent, or but with when we use simple, it's good or not?
Yeah, this is a bit of a discussion, right? So PLS, consistent PLS, is actually a way of correcting the initial PLS estimates to accommodate what we call a factor model. Yeah, the factor model is typically associated with reflective measurement, but there's some discussion whether this is actually appropriate, because reflective measurement basically just tells us from a measurement perspective, do we believe the indicators are reflections of a construct, or are they like kind of causes? It's not 100% the right term. Yeah, this is like the measurement level, how you think about measurement. This is, however, different of what the data actually look like. The data can follow a composite logic, meaning you can use the indicators as linear combinations to represent a formative or a reflective measurement model. This is very technical, right? And I hope I'm not confusing you. But there are two things, and many researchers that say, oh yeah, you should always use PLS when it's PLSC when it's reflective. In my point of view, and also Joe Hare's point of view, confuse these things. There's a measurement perspective where you theoretically establish the measurements, and there's the data perspective where you have to decide, okay, how can I represent these variables in a statistical model? I don't know whether a construct is measured with a factor or composite. Yeah, there's simply no way of finding out which one is the correct one. Yeah, in my point of view and other people's point of view. And therefore, I think the notion of PLSC is a good one, but it makes a certain assumption about what the nature of the data looks like. And it's not that easy to say if you have a reflective model, it's PLSC, and if you have a formative model, it's PLS. This is too short-sighted in my point of view. Yeah, so I know that if you're doing the wrong thing, meaning you have a factor model and you estimate it with PLS, that would be a mistake. The error in making this mistake is much less severe than doing the mistake in the other direction, meaning having a composite model and using PLSC. So from my point of view, using PLS is a safer option. But I acknowledge there are different researchers who have a different opinion here.
Thank you very much.
رقية, their important question to
Yes, in the chat box.
Munira al-Nuaimi
Yes.
in the chat box.
There are
asking
3
about
questions in
the
the chat box.
IBMA. Yes.
I don't. Okay, I would like to read the question. It's in the chat box. If everyone can see the chat box, there's a chat below. Okay. Asma or Mira? Okay, let me check. Okay, Mira Naimi asked. Mira Naimi asked, can a construct be the most important construct in IPMA, while the most important indicator for the IMPMA is linked to another construct?
Oh yeah, it can be. It's unlikely, but it could happen. Yes, yes. It's unlikely though. If the constructs, like say construct A is very important, construct B is also very important, but less so than construct A, then it could actually be that a much higher weight in construct B makes this indicator more important. Yeah, it could be, but unlikely.
Okay. Okay, there are 2 other questions from Asma al-Maghrani, I think. She is asking if we have a latent variable that consists of 3 or 4 indicators, and we want to test its effect as a monitor on the relationship between 2 constructs. What is the best way in the Smart PLS3 to get the best results? Do we convert the latest variables into 2 categories, high and low, or we analyze the latent variable as with its linked indicator?
Definitely the latter. Hold on, let me just show you that. Hold on, if I can somehow. Okay, somehow I can't. Ah, there you go. I hope you see that, right? I can just show you that real quick. So let's say you have some type of relationship, say competence to customer loyalty. And the best way of handling this would in fact be specifying the moderator as a continuous variable. Yeah, because otherwise, if you categorize it into like 3 categories or so, you're just losing information. And that's actually pretty easy to do. In Smart PLS, I've got that on this sample data set. I have a construct called switching costs, which are put in here. And I'm just going to link it to my construct. And then I can say, OK, I want to add a moderating effect. So if I want to add a moderating effect, I have to tell the program, OK, what's my moderator variable? This is the one that I just entered, add my independent variable, which could be, for example, I don't know, competence. Yeah, and then I get this so-called interaction term here. And this is something that you'll be familiar with. Interaction term tells us about the impact, the joint impact of the newly added variable switch in this case, and the independent variable comp. Yeah, so answer is always use the original scale, because if you recode it into, say, a categorical one, you're always losing information.
Okay, thank you again, Professor Marko, for the informative session. We apologize for everyone who's asking another question, but like time is done, and we know that everyone have a schedule for their day, so we are apologies. If you have any question, maybe you can send it to us by email, and we will try our best to get the answer for that question and send it back to you, inshallah. I'll just share the screen. Okay. Okay, if you would like to participate with us in the course and the PLS SEM course with Arkan Administrative Training Center, please just let me try to share.
Let me just stop mine and.
Thank you very much.
There you go.
Thank you. Okay. Okay, please just go to our website www.arkan.com.qa. You can find us also by email info@arkan.com.qa, or just call us by our phone or send us a WhatsApp on 974 3333-4280, and we will try our best to get to help you with a registration or answer your question. Thank you again, Professor Marko, for your time. Thank you again,
Thank you very
Dr.
much.
Zakaria and Mr. Ghassan, for your time to be with us here.
Thank you.
You're welcome.
Thank you, Dr. Marko. Again, actually, there are a lot of questions we didn't answer. Maybe our time is very tight, and I think 1 hour is not enough to cover very important subject, PLS SIM. But I promise all, we will organize another orientation as soon, and just we will make a double check and see the Dr. Marko's schedule as soon.
Sure.
Thank you,
No.
Dr. Marko. Appreciate it.
Thank you very much, everyone, for being here, for attending, and thanks for your questions. Yeah, let me know in case you have any. Just drop me an email.
Thank you again for everyone for attending. I hope you have a nice day.
Have a great day. Bye bye.
Have a great day. See you. Assalamu.